Assalamu alaikum. I hope you're all doing well. So, in this class, we'll be solving a past paper question related to the topic of kinematics, which includes graph. So, as we see in the question, there's a speed time graph they've shown to us. And if you look at the graph, if we closely analyze it, we see that the graph is divided into three portions. One portion which goes from time t equals 0 till around time t equals 0.12 seconds, which is a straight non-horizontal line. And then from time t equals 0.12 seconds, the next region goes till time t equals 0.2 seconds, which is a curved line, something like this. And then after this point, if you look at the graph, it's a straight line from time t equals 0.2 seconds all the way till time t equals 0.28 seconds. So this is how the graph is. Now if we analyze the graph, so if we look at the pink line represents a line of constant gradient. So the gradient is constant. And if you look at the red line, so the red line represents a line where m is decreasing, with the gradient of the line is decreasing. And then when we look at the yellow line, it represents a line where the gradient of the graph is 0, m equals 0. Now if we try to understand the gradients and in terms of the velocity, so the gradient of a speed time graph equals acceleration. So if I look at the pink region, so that's the graph for constant acceleration, and then the red region represents when the acceleration of the ball is decreasing, and the yellow line shows that the acceleration of the ball now becomes 0, and when the acceleration is 0 there is no change in speed, so the ball goes on to move at a constant speed. The speed is constant where the gradient is 0. So I hope this is clear to everyone. So now let's move on to the question. At time t equals 0, okay, so we'll be skipping the first part because that's related to terminal velocity and forces. Right now we're just focusing on kinematics, so we won't be doing that question. So part B, at time t equals 0, a different ball is dropped from rest. Until time t equals to 0.2 seconds, this ball has a constant acceleration equal to the acceleration of free fall. After time t equals 0.20 seconds, its acceleration decreases. Set the value of the acceleration of free fall. Now we all know this, that the value for the acceleration of free fall is 9.8 meter per second. Meter per second square. Previously in O levels, the value they would use for acceleration was 10 meter per second. They used to round it off to the nearest tenth. Now, since the recent syllabus has come up, the value they're now using is 9.8, and we can't round it off to 10 meter per second square. So this is the value of acceleration of free fall, which you all know. The next part states determine the speed of the second ball at time t equals 0.20 seconds. So we just need to figure out the speed of the second ball, and the information we know regarding the second ball is that at time t equals 0, the ball is dropped from rest. So if I want to give some initial values to the ball, so the initial value, so that at the initial value of time equals 0 seconds, and the corresponding value of velocity at this initial time equals 0 seconds, because 0 meter per second, the velocity is 0 because it's starting from rest. And then we have some final values. So if we look at the question statement again, so until time t equals 0.20 seconds, this ball has a constant acceleration equal to the acceleration of free fall. So the acceleration, we know that acceleration of the ball is equal to the acceleration of free fall, which is 9.81 or 9.8 meter per second square. So the final velocity, if we read the statement, after time t equals 0.20 seconds, so we know that the final time we're considering is time t equals 0.20 seconds. At this point the acceleration of the ball starts to decrease from 9.8. Okay, so now when it comes to question part B question, the second part of part B, determine the speed of the second ball at time t equals 0.20 seconds. So we know the initial values, that at time t equals 0, the velocity of the ball is 0. Then it accelerates at an acceleration of 9.8 meter per second till eventually it reaches time t equals 0.20 seconds. And at this point we need to find the corresponding value for the velocity of the ball. So velocity of the ball we don't know, so we just simply apply the formula for acceleration, we know that acceleration equals v minus u over t, or change in time. So where v is the initial final velocity, u is the initial, and change in time is the change in time. The final velocity is unknown, so I'm just going to name it as v. The initial velocity I know, that is, since it started from rest, it's going to be equal to 0. And the change in time, so the change in time, the final time was time t equals 0.20 seconds, and the initial time was time t equals 0.2 second, 0 seconds. So the initial time was 0 seconds. So the change is obviously equal to 0.20 minus 0, where I get v over 0.20, and this is equal to acceleration, which they've told me that the ball accelerates with the acceleration of free fall, which is 9.8. So we just simply solve this and we can get v equals 0.2 times 9.8, and if we solve this further, we would just simply get an answer of 1.96 meter per second, which happens to be final speed of the graph. On figure 1.1, draw the speed time graph for the second ball from from time t equals 0 till time t equals 0.28 seconds. So that's what they're asking me. Now when I go to the graph, so let me update this table of mine. So as per the table, the final velocity is supposed to be 1.96 meter per second. So let's go to the graph. This graph was previously for the original ball 1, and now we have another ball which is dropping. So how do we find the velocity of the second ball? So for that, we need to just draw a line and figure it out. So they've told me in the question statement that the ball has a constant acceleration from time t equals 0 till time t equals 0.2 seconds. That's what they've told me in the statement of question B. So I go with this statement and I try to solve this. How do I do this? I know that the line should be something like this, or something like this, or something like this. I don't know where do I draw the graph line. One way could be to just find a line whose gradient, by trial and error, find a line whose gradient happens to be 9.8, cause the gradient of this line would eventually be equal to the acceleration, which I know is 9.8. That's the difficult way. Other way could be that they've told me at time t equals 0.2 seconds, the ball has a velocity of 1.96 meter per second, which I just found out. So I mark the point time t equals 0.20 seconds, and I go with the velocity, and I mark 1.96 meter per second somewhere there. I've gotten the point. I have 2 points, time t equals 0, v equals 0, and time t equals 0.2, v equals 1.96. I simply use this information with me. So I have the 2 points. Now I could just match the points using a scale, and this would be the line. Now they tell me that this is now I'm done with drawing the speed time graph till time t equals 0.2 seconds. But in the question they've asked me, draw the speed time graph for the second ball from time t equals 0 to time t equals 0.28 seconds. So there's some 0.8 seconds remaining. How do I plot them? They've told me that after time t equals 0, its acceleration decreases, meaning that the line should be such that the gradient of the line should be decreasing. Why? Because the gradient of the speed time graph equals acceleration, and since acceleration is decreasing, I should draw a line whose gradient would be decreasing. So I just need to carry on with this line from this point where I just left this, in such a way that I draw a line whose gradient is supposed to decrease. That's what I do, and by just simply doing this, I'm done with the question. I hope this is clear to all. In case of any questions, feel free to ask them out.